In this video, we use the pumping lemma to prove that a language is not context-free. And we are going to prove that if we have NAs followed by NBs followed by NCs, so that the number of A's, B's and C's is the same, this language is not context-free. It's not context-free. And the proof is by a pumping lemma. So we assume that L, this language here, NAs, NBs, and Cs, is context-free. Then we know that by the pumping lemma there must be a P, this constant P. Then by pumping lemma there exists the constant P. Now we choose a word that's long enough, and the simplest word we could come up with is probably that we replace the N just by P. So we consider the word where we have PAs followed by PBs followed by PCs. This one is obviously in the language, and we know that also the length of Z is greater or equal to P. So by the pumping lemma there must be a decomposition into 5 parts. So then Z has the form U V W X Y with Vx, it's not the empty word, and the middle part, Vwx, has at most p characters. So we know that this middle part, however this 5 parts, whatever they are, however the decomposition is actually done, what we know is that the middle part, Vwx, has at most p characters. But if we have at most p characters, then we know that this middle part cannot contain all 3 kinds of characters. It cannot contain A's and C's. That's impossible, because there are PB's in the middle. So the middle part of the B's here has already p characters. So in our Vwx, it's impossible to have A's and C's, or to have all 3 types of characters. That cannot be. So we know that Vwx cannot contain all 3 types of characters. So what happens if we pump down? So when we pump down, and consider the word U, V is removed, W, X is removed, Y, which is the word U, W, Y, this word should be in the language. However, we remove V and X, and as we remove V and X, we cannot remove all 3 types of characters, because Vwx cannot contain all 3 types of characters, so Vx cannot contain all 3 types of characters either, because it's a subword. So when we pump down, we remove characters, because we remove something, but we cannot remove all 3 types of characters. So pumping down to this one, to cannot remove all three types of characters. If we do not remove all three types of characters, the word is no longer in the language, because the language requires that the amount of A's, B's and C's is equal. So when pumping down, we find a word that's not in the language. So this word here, U, V, Y, is not in L, because the amount of A's, B's and C's is no longer balanced, no longer equal. And this actually a contradiction to the pumping lemma, so we can conclude that the language is not context-free. So this leads to a contradiction. So the assumption that L was context-free is false, so L cannot be context-free.